Hey everybody, the Network Berg here. Hope you're doing well. In today's video, we'll be going over 802.1q. What the hell is that? it's VLANs. If you're not familiar with VLANs, or if you maybe just need a recap on how VLANs work, this is a perfect video for you. I will be explaining and showing to you what a VLAN is, what we use it for, and what happens, what is the process. Because a lot of people, and I know myself, when I started working in telecommunications, I worked for years on routers and switches. And yes, I've configured VLANs, but I didn't really understand what was going on. So this video is aimed at helping people to just better understand VLANs, to see what they are doing. Before we jump into the video, I just want to remind people to subscribe to the channel and like and reshare the video if you do find any value in the content. It does help grow the channel, and I do appreciate that. So let's jump into the video. Alright, so we're in Eve. We've got a basic blank topology here. So let's go ahead and just add ourselves a couple of nodes. So in my case, I'm just going to add some Dockers, which will function as computers for us to test with. Let's give them a nice desktop image so that they look like computers. There we go. 4 of them is fine, just one Ethernet port, that should be fine. So I've now got my 4 Dockers. I'm just going to position them in a way that makes sense. And there we go. Those could be 4 individual computers, and 2 of them might be in your corporate VLAN and 2 of them might be in your sales VLAN. So next thing I'm going to do is I'm just going to add a switch. So let's add 2 of the Cisco viral switches. These ports are fine, and we'll telnet to them as well. Alright, cool. Now I've got 2 switches. So this topology should already look pretty basic, something that you might be familiar with. And let's also just add a router. I'll add a MikroTik just to show you don't need vendor to vendor. It is a industry standard, guys, and that's the cool thing about VLANs. All of the routers, all of the switches, they all, if they support VLANs, which they should, it works the same. The configuration might look different on the devices, but they do the same thing. The process is the same, and they'll have the same options. Just how you type the command might be a little bit different, and that's what I want to stress. Industry standard things like VLANs, if you know one, you know them all. You don't need to relearn how to do VLANs for, let's say, a Juniper if you know how to do it on Cisco. Again, commands are different, but same principle, and the exam questions are going to be relatively the same as well. So I'll also just maybe add a firewall just to show you something else with the VLANs. And this is just a normal FortiGate. So this might look pretty normal to you. I mean, this might be a network that you've worked with before. You've got computers, got them going to switches, and then from the switches there will be uplinks to the router and the firewall. I'm just going to uplink the 2 switches with each other as well. You can imagine that the switch 6, this will be our core switch, and this will be connecting directly to our firewall and our router. And then let's just uplink the switches with each other. Once that is done, our topology is ready, and we can start this up. So I'm just going to start everything, and I'm just going to pause the video while everything is starting. Alright, so my switches have started up, and I just want to show you now what is happening specifically between the clients, like the computers, and the switch, or switches in our case. Because a lot of people, they tend to start overthink VLANs and thinking about the whole network. So I want you to cut off this MikroTik and FortiGate for now, because we'll add some VLANs on them. But I want you to focus on this part for now, the computers. Because I'm sure you're aware, whenever you buy a switch, do you know how many broadcast domains a switch comes with? It comes with 1. And that is the default VLAN, which is VLAN 1, which is running across the switch. So what VLANs allow us to do is to split the switch up into different broadcast domains. What is a broadcast domain? Well, it's ports that broadcast traffic will be sent out of. So in our I have a video explaining what switches do, but in essence, when a switch receives a frame and it's trying to learn MAC addresses, it will flood broadcast traffic out of all ports to try and learn where this MAC address is for the frame. So in terms of VLANs, whenever the switch receives the packet, or not packet, the frame, it's going to look at the port that it comes in, and if that port has a VLAN associated with it, the switch will then add a VLAN header, which is a 4-byte header, to the frame, which will identify which VLAN this belongs to. So an example would be, let's say Docker 1, it's trying to connect to Docker 4. Let's say 1 and 4 will be in the same VLAN, and they'll be in VLAN 100. So Docker 1 will try and get to Docker 4's IP address. So they communicate on IPs, but remember, the switches are not, they don't care about the IPs. They're just there to send frames. So what will happen is it will receive this frame, and once it receives the frame, it will check, okay, the port it comes into, it's on access 100, or it's untagged for VLAN 100. Then what the switch will do is it will look at all of its ports that has VLAN 100 associated with it. So if this Docker 2 has VLAN 200, it's not going to send that traffic over the port that's connected to Docker 2, but it will see there is an uplink here, and VLAN 100 is tagged there, or it's a trunk, so it will send the frame across to this switch, and then this switch will then follow the same process. It will look at its ports. It will say, okay, I've got this frame, it's got this MAC address in it, and this IP, I want to learn it, so I'm going to flood all my ports that's got VLAN 100 associated with it, and then it will send it out over the corresponding ports where VLAN 100 is. And that is how Docker 4 will then finally receive that frame, and then these two computers have direct communication with each other. And this happens without a router. Broadcasting and intra-network, not intra-network, but inside your own network, that happens locally. So that happens between computers and switches. That happens on the same subnet. The only time that different subnets need to communicate with each other, that's when you need a layer 3 device like a router or a layer 3 switch or a firewall, something that can do layer 3 traffic that you can use as a gateway. And that's where you get the term router on a stick, where let's say Docker 2 wants to get to Docker 1, but the switch, even though they're connected to the same switch, they're not going to forward packets to each other or frames. It will first go to a router, and then let's say the router is the default gateway, and then from there it will push it back into the network to the right subnet. So that is in essence how VLANs work. Why do we need them? Well, they are really, really secure. As I just said, the switch will only send the VLAN information over which ports you've defined. So it's great to split your network up. Let's say you have maybe a corporate network and a technical network and a sales network, and you don't want them to necessarily have access to the same resources. You don't want them to be able to connect to each other directly. That's something that you can use VLANs for, and it will save you a lot of time in the long run, because the more your network grows, the more devices are connecting to it, the bigger the broadcast traffic becomes. So you don't want to have one big flat network. You don't want like a 192.168.0.0/16. You're eventually going to run into some very, very bad issues, especially when it comes to broadcast. So plan your networks ahead. Think about how many IP addresses you need for a specific site or group. If it's a small group of people, they're 30 people, you essentially just want to have to plan for some growth and then some, like 10% more IPs as well. So if it's 30 people, maybe give them only a slash 26. I mean, give them 64 IPs. Don't give them the whole pool, because now essentially you've got 3 more slash 26s that you can assign however you want. So that's something that you need to take into account as well. Alright, so let's actually get into configuring these switches so that I can show you what is happening when we want to send packets across. So here I've got switch 5 and 6. Let's just switch them around before I confuse myself. So in switch 5, I'm just going to enable, and let's play out that scenario. Docker 1 and Docker 4, let's put them in the same VLAN. So I'm just going to go into interface GI00, I'm going to put it into an access mode, which means all the packets that leave the port will be stripped of the VLAN, and that will be on VLAN 100, but all the frames that come in will be added with that VLAN 100. So switch port access VLAN 100. It will create the VLAN. So I'm just going to go into that VLAN as well, and I'm going to give it a name, let's say Corp. Great. I'm going to do the same on interface GI01, but this time I'm going to give that VLAN 200. Switch port access VLAN 200. Okay, VLAN 200. Let's call this sales. Gonna jump out of the config there. Actually, there's one more thing I need to configure, and that's my trunk. So let's just go into interface GI02, switch port trunk encapsulation .1q. .1q is what people informally call 802.1q or VLANs. Switch port mode trunk. So on Cisco, if you leave it like this, that's basically sending all VLANs across. If it's just a trunk with no allowed VLANs or a native VLAN, it's just going to send all the VLANs across the trunk. And that's great for just inside a small network between two switches. But if you get a bigger corporate environment, you might want to put on some security, like specifying which VLANs can go across. Alright, so let's jump onto switch 6. Same process. I said Docker 4 will be in VLAN 100, so let's do that. Interface GI01, switch port mode access, switch port access VLAN 100. Interface GI00, switch port mode access, switch port access VLAN 200 for sales for Docker 3. You don't need to give the VLANs names. I just like to give them names because it makes them easier for me to identify if I look at the VLAN tables. Name Corp, VLAN 200, name sales. Okay. And what I mean about that is all the switches have like a VLAN table where it knows which VLANs are associated. So with Cisco, we just do a show VLAN. It will show us VLAN 1 is associated with all these ports. Corp is on that port. Sales is on that port. So now we have our VLANs associated with our ports. So technically, these machines should be able to see each other in their own broadcast domains. So let's quickly configure that. I'm just going to close off these switches for now. I'm going to jump on Docker 1. Going to jump on Docker 4 because these two are in the same VLAN. So what I'm going to do is I'm just going to give both of them IPs. So ifconfig eth0, let's make it 172.16.0.2 in the /24. Actually, let's make it a /25 and let's just bring this up. And I'm going to do the same on Docker 4. So this will be ifconfig eth0 172.16.0.3 netmask 255.255.255.128. Remember the netmask, that is the subnet, so that is the broadcast domain. That is where the network will be communicating locally at. So let's quickly check. Can I ping myself? Yes. Can I ping the other device? Yes. So essentially we've spanned that VLAN 100 across both switches, and these two hosts or computers now talk to each other directly. Let's do the same now for the other two computers, Docker 2 and 3, and they will be part of VLAN 200. And you saw I didn't configure any VLANs on the Dockers. It's since the port is untagged on the switch, you don't need to configure the VLAN details on your host. It's only whenever you're tagging that you need to make sure that you have it as a VLAN on your host. Okay, so let's do Docker 2 ETH ifconfig eth0, and let's put this in the 192 range, 192.168.0.2 net mask, and I'll make this a /24. Let's do the same on Docker 3, ifconfig eth0 192.168.0.3 net mask 255.255.255.0 and bring it up. if I need to type ifconfig. There we go. So from Docker 3, let's see, can I ping 192.168.0.3? I can ping myself. Can I ping .2? Yes. So we've spanned the VLANs across, and the hosts in the same network can talk to each other. Let's quickly see what happens if I try and ping 172.16.0.2. Do you think it's going to work, or do you think it's going to fail? I'll give you a second. So let's see. It's going to fail. And it comes back to the point that that network, it's not part of our broadcast domain, it's not part of our VLAN. We would need a gateway in order to reach that. So in that case, we would most likely need to configure this MikroTik or FortiGate in order to be used as a gateway. So typically you might put the gateway up at the firewall, and then the MikroTik you'd use for your routing or your router. So I'm going to configure this on the MikroTik actually. So I'm just going to log on to the MikroTik, and I'm quickly going to just add two interfaces. So interface VLAN add. Let me just quickly make sure which port it is. ETH1. So VLAN add. Let's call the name corp. VLAN ID was 100, and the interface it's on is Ether1. I'm going to do the same for VLAN 200, but that we're going to call sales. Now I'm just going to add the IP addresses, similar as I did on the Dockers. So 192.168.0.1/24, and that was for sales. And then 172.16.0.1/25, that was for corp. Let's quickly see if I've got access from the router. 192.168.0. Let's ping ourselves. Let's ping one of the hosts. Why is it failing? I have a suspicion I know why it's failing, but I wonder, do you know why it's failing? I'll give you another second. And the reason it's failing is we never did the trunk on the switch going to the router. So let's quickly jump onto the switch, and let's configure this for a trunk quickly. Interface GI03, switch port trunk encapsulation .1Q, switch port mode trunk. Let's save that. So now let's quickly go back to our MikroTik. Stop that. Sorry, it just sometimes take a little bit of time for these viral images to catch up with what's going on. So we can now ping across from the MikroTik to our hosts. Let's quickly see, can I ping my 172 IPs, 172.16.0.1.2.3. Alright, so I've set this up so these Dockers can now get to the MikroTik as well, and they're going to use this as a default gateway. But do you think before we specify the gateway that they can reach each other? Let's quickly see. No, they still cannot reach each other. So let's specify the MikroTik as the default gateway, and then let's test again. Alright, so let's add that default gateway. We can do that by typing root add default gateway. And this is Docker 2, so that is 192.168.0.1. I'm going to do the same on Docker 3, root add default gateway 192.168.0.1. Cool. Let me jump onto the other two Dockers. I can close the switches off actually. So just closing down the switches because we're not going to add more config to them. I'm actually gonna stop with the firewall section. I'll show that to you in another video. So let me just delete this as well. And let's jump back onto the Dockers. So I've got Docker 1 and Docker 4. So Docker 1 and 4, same principle. Root add default gateway 172.16.0.1. Same thing for Docker 1, root add default gateway 172.16.0.1. Will our devices be able to communicate now? Let's test. 192.168.0.3. Yes, they can connect. And that is because we are using this router in order to broadcast the VLAN traffic. Well, not broadcast, but forward. It becomes a forward. It's no longer a broadcast, it is a forward. So it's forwarding the traffic for us back into the switch to the correct VLAN. And now these two networks can communicate with each other. So I'm going to end off the video here. I do hope this has been informative and it has given you some more insight into how VLANs work, what they are, how we can use them, and that you don't need to stress when you think about setting up VLANs. It's literally just think of it as a label that you put on a switch port. I'd like to thank you again for watching. Catch you in the next video. See ya.